In this video, I will be talking about how to find the basis vectors in spherical coordinate. Now, why am I doing that? Well, it's because in the next video about Christoffel symbols, we need to understand what basis vectors actually mean. So, let's just start. Now, we have this direction vector. We have these direction vectors r hat, theta hat, phi hat. Now we want to be able to express them in terms of I hat, j hat, and k hat. How do we find that? So let's just write our x coordinate, y coordinate, and z coordinate of this vector right here, say vector r. Right, now we want to be able to write the x coordinate, y coordinate, and z coordinates. What are the x coordinate, y coordinate, and z coordinate? Well, for finding the x coordinate, we will be doing some trigonometry. So this length right here is just sine theta. And so this x coordinate would be r sine theta cosine phi, and this vertical section right here would be r cos theta and this y coordinate would be r sine theta sine phi, and the z coordinate is just r cos theta. Right, so let's write the x as r sine theta cosine of phi, y is equals to r sine theta sine phi, and then z is just equals to r cos theta. Now let's change this vector. Let's make a change in theta and say after making that change we have a different vector. Right, a different vector. Now let's call this center O. Let's call the original endpoint of the vector P, and now let's call this P primed. Right, now we want to be able to find this change right here. Oops. We want to be able to find this change right there. This change, say that's PP primed. Now how do we find that change? And this angle is just d theta. So our p primed coordinate, let's write it here. P primed coordinate is just r. We made a little change in our theta direction, and the final coordinate should be phi. Right, see, we haven't just made any changes to our r's and phi's, but we have made our change in theta direction, a tiny little change. Now let's find the vector PP primed. What's PP primed? Well, it's just minus OP plus OP primed. Right, now what is OP vector? Well, OP vector can be written in terms of r's, thetas and phi's. Well, how do we do that? Well, we have already found our components in the x, y and z direction, so that would be easy. So OP vector would be in the x direction, meaning in the I hat direction we have, let's give a bracket here, third bracket, this should be r sine theta cosine phi I hat plus r sine theta sine phi in the y direction j hat plus r cosine theta in the z direction k hat. That's our OP vector, plus OP primed vector. Now OP primed vector would be the same, but in place of theta we would just put theta plus d theta, right? So this should be r sine theta plus d theta cosine of phi I hat plus r sine theta plus d theta sine of phi j hat plus r cosine theta plus d theta. That's in our k hat direction, right? So now what we would do is take r cosine phi common. R cosine phi, well, in which terms do we have r cosine phi? It's this term right here, and then this term, and the rest of them we don't have cosine phi, so it should be sine theta minus sine theta plus sine theta plus d theta. That's just in the I hat direction, right? Now let's take common r sine phi. We have our sine phi's here and then here. They are both in the j hat direction, so this should be sine theta minus sine theta plus sine theta plus d theta in the j hat direction, right? And then finally we will take r common because we have only two terms left, so r, and this should be cosine of theta plus d theta minus cosine of theta, which is basically in the z k hat direction. Now we are familiar with these terms right here. They look familiar, right? How? Well, they're basically the f of x plus h minus f of x, isn't it? We know this from calculus, the first principle, right? So we want to be able to express this in a more simpler manner. We want to be able to express sine theta plus d theta minus sine of theta in a more simpler manner. How can we do that? Let's see. So let's say we have f primed of x is nothing but f of x plus h minus f of x divided by h. So if f of x is sine of theta, then what's f primed of x? Well, that's cosine theta. When we have cosine theta, and f of x is just sine theta, and f of x plus h is just theta plus d theta. Oops, this theta here. And then we have divided by d theta. Right, so this term right here, sine d theta plus theta minus sine of theta, is just basically d theta times cosine of theta. So this should be r cosine of phi cosine of theta d theta in the I hat direction, and then similarly r sine of phi, this should be in the cosine theta d theta. These cosine thetas are in brackets. This should be in the j hat direction, plus the final term, which is cosine theta plus d theta minus cosine of theta. We can write that as r into, this is basically the derivative of cosine theta. So what's the derivative of cosine theta? Well, it's minus sine theta d theta, because we don't have that infinitesimal length in the denominator, so we're multiplying by d theta, and then this is in the k hat direction. Now let's take, we can see that we have r's and d thetas common in all these terms. So let's take r d theta common, and then we have cosine phi cosine of theta in the I hat direction plus sine phi cosine theta in the d theta, in the j hat direction, and then we have minus sine of theta in the k hat direction. Now this is just our PP primed. Now let's find the length of PP primed. This vector, length of this vector. So it should be let's say we're going to square all these terms, and so we have r d theta on the outside, and then this should be cos squared of phi cos squared of theta plus sine squared of phi cos squared of theta minus sine squared of theta. I hope you're able to follow on that, because that's just finding the length using the Pythagorean theorem. So this should be, well, we can see that if you take cos squared of theta common in these two terms, we end up with cos squared of phi plus sine squared of phi, which is basically 1. So if we end up with cos squared of theta from these two terms, then minus the sine squared of theta, sorry, this shouldn't be a minus, this should be a plus. right? When we're finding the length, we don't keep the minus, we're just adding them up using the Pythagorean theorem. So if we end up with cos squared of theta in these two terms and then add it with sine squared of theta, that's just basically 1, and square root of 1 is just 1, so we're left with r d theta. So the length of this pp prime vector, is just r d theta. Now we want to be able to understand what's pp primed. Well, pp primed is just basically the change in our theta direction. I mean, a vector that represents the change in our theta direction. Why? Because initially we had r thetas and phis, and now we're saying that we have r theta plus d theta and phi coordinates. So we're basically making the change in the theta direction. So our vector should also represent the change in the theta direction. But theta hat, we know theta, change in theta, we know the direction of theta, but we want to be able to find a unit vector that represents the direction theta. So what do? We take the direction of theta, which is just pp primed, and then divide by its length, isn't it? Which is basically saying the vector pp primed divided by the modulus of pp primed. Right, so let's find that. The modulus of pp primed is just r d theta, and pp primed is just r d theta, and in the brackets we have cos theta cosine of phi I hat plus sine of phi cosine of theta j hat minus sine of theta in the k hat direction. So let's just cancel out these r's and d thetas from the top and bottom. We have got left with cos theta cosine phi I hat plus sine phi cosine theta j hat minus sine of theta k hat. That's just basically our theta hat direction. Likewise, we can find phi hat direction and r hat direction as well. I don't think we need to do the same step for r hat direction. We can just basically find our phi hat, and we have already found theta hat, and then we can do the cross product, right, of our phis, and we can do the cross product of our phis and phi hat and theta hat. We can get the r hat vector. How? Because notice that phis and theta hat, when we do the cross product, we get a perpendicular vector, unit perpendicular vector, that is pointing in the r hat direction. So we can just do the cross product. Now let's talk about a more crucial fact from this derivation. What is the vector theta hat? I mean, we did our calculation, but we want to be able to express this calculation in a more compact manner. Let's take a look at what this is. Now, let's say we have we're saying that this is basically del r by del theta divided by its modulus del r by del theta. How is that? How can we say that? Well, notice that we have the vector, say, r theta plus d theta comma phi, but if we write our original vector, well, our original vector is just OP, right? OP is just this part right here. Now if we take the derivative of our original vector with respect to theta, what do we have? Well, all we have is just r cosine phi cosine of theta. Let's write it down. R cosine phi cosine of theta in the I hat direction, and then we have, where's our OP vector? And then we have r sine phi cosine theta in the j hat direction, r sine phi cosine of theta in theta in the j hat direction. Notice we are only doing the partial derivative, so the final term would be r minus r sine theta in the k hat direction. This should be a minus. In the k hat direction. Now if we take the modulus of this term right here on the top, we would get r square rooted of square rooted cos square of phi cos square of theta plus sine square of phi cos square of theta plus sine square of theta. Right, now if we take cos square of theta common in these two terms, we are left with sine square of phi plus cos square of phi, which is just 1, and then cos square of theta plus sine square of theta, which is 1, and the square root of that leaves us with 1. So basically we have this r on the bottom. Now if you cancel out the r's from the top, we are left with just cos phi cos theta in the I hat direction plus sine phi cos theta in the j hat direction minus sine theta in the k hat direction, which is basically the thing we have proved with using vectors, right? You can see that these terms match right here. So that's our definition of unit vector. Now when we will introduce Christoffel symbols, we will need the definition of basis vector, or I should say unit vector. So in the next video we will be talking about Christoffel symbols, and so see you in the next video.